Unobtainium. Unobtainium is that resource that we're here on Pandora to get. Let's listen to it.
This is why we're here, unobtainium. Because this little gray rock sells for 20 million a kilo. It's what pays for the whole party. Comprendo?
So this is what they're mining. They're doing the strip mine and knocking down the woods so they can get to this unobtainium. Apparently, it is a room temperature superconductor. So you're looking up here on the wiki. Got to zoom in here. It is a room temperature superconductor for energy. Okay, I'm not sure what that means, which makes it very valuable. So room temperature superconductor would be world changing.
It would be, because then we could push around electricity anywhere we wanted without having to either cool it down, which is expensive, or encounter the thermal resistance.
That's right. And we could store energy in persistent currents. There's all kinds of stuff, and probably things we haven't even thought of yet, that once the technology starts to take off, like all these different applications will come into
Once you
being.
see what it can do, then you start doing stuff.
Yeah. So the fact that it actually makes sense that we're kind of knocking down forests and killing natives for this stuff because it's so useful.
Well, it would be species changing. It would change how humans operate if we had a room temperature superconductor.
That's right. And if this is the only place to get it, then Navi,
you go get it. You get it.
You get it, yeah. And if I'm sitting on Earth and I just pretend it's not, atrocities aren't being committed, I'm cool because I got my cool computer. I'm gaming.
That's right. And my room's not getting all super hot in the summer because of the heat. Like, no, it's super cool.
Yeah,
room
super
temperature.
Cool. Yeah. Mm-hmm. That's messed up. So
what's messed up? All this stuff's happening far away. Yeah.
Far away. I don't even know.
I just bought the product. I don't know.
Yeah. So it actually makes sense why so much is being invested in the facilities on Pandora because of unobtainium. Question is, what is unobtainium? Is it an element?
I don't know.
Because if it's a compound,
if it's a compound, why don't we just make it ourselves?
We just make it ourselves.
Yeah.
Which somehow means it's difficult to make.
And also difficult to reverse engineer. Because even if it was some compound with some magic doping composition, well, we could just figure out what that is and then make it.
But I guess it could be an isotope of a particular element that somehow turns on magic superconducting properties, but we can't manufacture it in sufficient quantities because it's nuclear.
And it requires the radiation from the planet nearby.
Ooh. Okay.
Oh.
Okay. And we just
the radiation from the planet nearby does some type of magnetic field confinement that controls the isotope effect. I said words. None of that made sense.
None of that made sense, but it could be an isotope of a known element. So we're not making something new. Plus, he's holding it in his hand, and I feel like if it was a unknown element, it would have to be really high up on the periodic table. Which would make this super heavy, I think, because he would have, even for something this size, it would be.
You mean like physically heavy?
Physically heavy.
Be a struggle for him to hold.
I don't know if a struggle, but it might be.
I guess more challenging
because he just whips it.
Unobtainium, because this little gray rock sells for 20 million a kilo. It's what pays for the whole party. Comprendo?
And it looks like he can hold it with just 2 fingers. If it was twice as heavy as gold, say, it would. I don't know if gold that size is still chunky.
I've never held a chunk of gold that size.
I guess I've held lead. And
that's right. And even that would be pretty heavy, so it would be even heavier than that.
Right. Yeah, with gloves on.
Oh yeah.
Okay. Yeah. So, and mercury, I've held a bottle of mercury. It's heavy. So if it's a new element, it would have to be really high up on the periodic table, which would make it even heavier. So
that's right.
Yeah. So I think our guess that it's an isotope of a known element may be the best guess.
Sure. Gosh, but that means it's a time unstable resource. Right? Because I guess is it possible for an isotope up there to be on the heavy end of the periodic table to be stable?
There is some theory out there that there's like an island of stability. Do you know what I'm talking about?
I think I've heard
Let's look
this.
it up. Island of stability.
So if you have atoms, if they have too many protons or too many neutrons, then they decay into other stuff.
That's right. So I think this picture right here. So we're looking at high neutron count, high
On
proton
the
count.
x-axis, on the y-axis. Okay.
Okay. And I think they're saying up here, I don't know where that is on the periodic table. I think this is beyond the periodic table. They have theoretically determined that there could be an island of stability out here where these are stable over a year. So that would be pretty stable. Let's see if we can get some. So let's see this. These dark red ones are totally stable.
Wait, our axis flipped. So on the horizontal axis is proton count, vertical axis is a neutron. So when you're at larger atoms, you need to have more nucleons, so with more neutrons for the atomic stability. Okay, I see this.
Yeah, and I think we're looking at like maybe around 90 to 100. There's an island of potential stability up here with neutron counts of about 150. And so,
I see.
Yeah, if we look at the periodic table, where are we looking? So let's get an image. Okay, so it looks like oganesson, I never heard of that, is named. It's a noble gas, and that is 118. So that's 118 protons. So the island of stability is sitting at, wait a second. I think it's got to be beyond this. This theoretical island of stability has got to be beyond that.
Oh yeah, well, I mean, that was a graph of the stability of known nuclides, which I mean, if it's already known, then we're not.
I see. So I think, okay, we flipped our axes again. So there's proton number on the y-axis, neutron number on the x-axis. I think this is our island of stability up, but we're looking at 130.
Can you point out ognium, ballpark it? It was 118.
So we're looking, this is 120. So it's this horizontal line.
Okay, so the island of stability is perfect.
Beyond that up here. That must be it.
Cool, so, yeah. So this unobtainium could be that stuff.
Could be one of the things up here. Yeah, could be.
Cool.
Okay.